These are homework problems for page 291, and I know that you've been assigned to do odds and evens. However, I'm only going to work out the odd problems because the evens parallel the odd problems. So if I do the odd problems, you should have an example that will help you to understand how to do the parallel even problem. So here we go. Problem number 15. Remember, we are finding the antiderivative of a given function. So this expression right here between the integral sign and the dx is a derivative. So we're going to we're going to anti-differentiate. We're going to go backwards and we're going to reverse the power rule. So we're going to increase the power on x by 1, so that becomes x squared, and divide by the new power. For the second term, for 3, when we increase the power by 1, we bring back the variable of x. And remember, there's always a plus c, a constant of integration, because these are a family of functions that share the same derivative. So the plus c is very, very, very important. Make sure you include that every time you find a general antiderivative. Number 17. Again, we're going to reverse the power rule. So in number 17, we're going to increase the power, so that becomes x to the 4th divided by the new power of 4 plus 5x, and then there's constant integration plus c. Don't forget the plus c. Problem number 19. In problem number 19, go slow, you have a fraction power, so we're going to increase the power by 1. So if I take the power of 3/2 and I increase it by 1, so I'm going to rewrite that as a 2/2. That'll give me x to the 5/2, and dividing by 5 over 2 is the same thing as multiplying by 2 over 5. Remember, when you divide, you multiply by the reciprocal. So that's x to the 5/2 multiplied by a coefficient of 2/5. For the second term, we're going to increase the power by 1. So that'll give me x squared, and there is a 2 there. Well, I'll go ahead and write it. And we're going to divide by the new power of 2, which is going to divide out, just leave me with x squared. And the antiderivative of 1 is going to be x, and the constant of integration is plus c. All right, so that's up to number 19. Moving on to, let me clear this off. Moving on to number 21. Number 21 is our first time that we have to do a rewrite. So the first thing we want to do with 21 is to rewrite that so that the variable is not in the denominator. We're going to make that x to the negative 3 power. So that's still the original problem, just re-expressed. So when we increase the power by 1, so we have x, and if we have negative 3 and we increase by 1, that takes us to the negative 2. And then divide by that new power of negative 2. And then that's plus c. This could be written, if you're checking answers with the solutions manual, I'm pretty confident that they would rewrite this as negative 1 over 2x squared. They would take that negative power to the denominator. Not really important for us to worry about that right now. If you get the first answer, you're good to go. Don't forget plus c. For number 23, 23 is a really important problem. Pay very close attention. You will see this many, 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 many times throughout this course. So we can only reverse the power rule, so therefore we need term by term situation. So the first thing we're going to do is a rewrite. And the algebraic rewrite is going to be to take one fraction with one denominator and make it into 3 fractions with its own denominator. So I'm going to have x squared over x to the 1/2 power plus second term x over x to the 1/2 power plus 1 over x to the 1/2 power dx. That's just a rewrite. Haven't done any calculus yet. Going to keep cleaning up. And so when I simplify, I want all my variables and their powers in the numerator. So that'll give me x. So here I have 2, which is 4/2, minus 1/2 gives me x to the 3/2. In the second term, I have x to the first power, which is 2/2, minus 1/2 in the denominator gives me x to the 1/2 power. And then for the third term, I'm going to bring that x to the 1/2 from the denominator to the numerator, and that'll give me plus x to the negative 1/2 power dx. Still, we're still in the rewriting phase, so we did some fraction work, we did some exponent work, so now we're going to find the antiderivative. All right, the antiderivative using the reverse power rule is to increase the power by 1, so 3/2 plus 2/2 makes 5/2. Dividing by 5/2 is multiplying by 2/5. That's the first term. For the second term, when we increase the power by 1, so 1/2 plus 2/2 makes x to the 3/2. Divide by 3/2 is to multiply by 2/3. And for the last term, when we increase negative 1/2 by 2/2, we get x to the 1/2. Divided by 1/2 is to multiply by 2. And then there's plus c, the constant of integration. So the rewrite, you really can't do any calculus whatsoever unless you do the complete and thorough rewrites on that. All right, let me clear this and go on to number 20, clear the annotations. And let's go on to number 25. In number 25, we do not have a term-by-term situation, so we're going to have to multiply the two binomials together. So when I do, that'll give me 3x squared minus 2x plus 3x minus 2 dx. Combine like terms, and I get 3x squared plus x minus 2 dx. Now I have a term-by-term situation, so I can reverse the power rule, increase the power by 1, and divide by the new power. So the 3 in the numerator and the 3 in the denominator will divide out. Increase the power by 1 and divide by the new power. And increase the power by 1 and divide by the new power. Don't forget plus c. Problem number 25. In 27, we do not have a term-by-term situation. We have multiplication. So we're going to do our little algebraic rewrite here. This will be y squared times y to the 1/2 power dy. And so that'll give me, when I keep the base and add the exponents, that'll give me y to the 5/2 power. So now I have one term, one power, and it's no longer a multiplication. To reverse the power rule, I'm going to increase the power by 1. So that'll give me 5/2 plus 2/2 is 7/2. Divided by 7/2 is to multiply by 2/7 plus c. 27. In number 29, it looks like there's nothing there, but you may assume that where they have the integral and then they have the dx, you may assume that there is a 1 there. So when we find the antiderivative of the number 1, we get x plus the constant of integration c. Don't forget plus c. All right, let me clear the annotations here and let's get down to the ones. I know we left some of these out, so let me look at my assignment. We are omitting 39 to 42, so let me go ahead and cross those out so I don't do them. So we're omitting 39, 40, 41, and 42. Okay, so in number 31, we are reversing trigonometry. So now we have to think of our trig derivatives backwards. So think of it like this. What function has a derivative of sine? Well, the antiderivative of sine is negative cosine. So that's going to give me negative 2 cosine of x plus, and then we're thinking, what function has a derivative of cosine x? Well, the derivative of sine is cosine, so that gives me 3 sine x. So we're going backwards. And whenever you do trig, it is very, very dangerous because you have the positives and negatives, and you have to get those correct. So always go back and take the derivative, oops, plus c. go back and take the derivative. The derivative of cosine is negative sine, so that would give me my original 2 sine x. The derivative of sine x is cosine x, and so I check it by taking the derivative, because my positives and negatives on the trig stuff can really give me a problem. Number 33, I have a multiplication right here. That's not just a coefficient, so let's clean that up a little bit, and then let's rewrite that as 1 minus, cosecant is 1 over sine x, and cotangent is cosine x over sine x. And so that's going to give me, so actually in looking back at this, you probably caught this before I did. I did not need to do a rewrite. I just wasn't thinking very clearly. Because there is a function that has a derivative of cosecant cotangent. All right, so let's start this one again. So in number 33, the antiderivative of 1 is t, not x, because we are in terms of t for this problem. The negative is already there, so we're good to go. So think about which trig function has, and so you need to go back and do your flashcards for the trig derivatives, and think about them backwards. What function has a derivative of negative cosecant cotangent? And that would be positive, because cosecant t plus c. Okay, number 35, first term, the antiderivative of sine. So we know that the derivative of cosine is negative sine, so that's going to give us a negative 2 cosine x, and then the antiderivative of e to the x is, we know e to the x is its own derivative, so when we undo it, it's still just as easy. We get 5 e to the x, and then plus c, don't forget the constant of integration. Then go back, because it's tricky trig, and take the derivative of this term right here. The derivative of cosine is negative sine times 2. Gives me what I originally had, which is 2 sine x. Always check your trig. Number 37. Think about the function that has a derivative of secant squared. And the trig function that has a derivative of secant squared is tangent. So the antiderivative of secant squared theta is tangent theta, and the function that has a derivative of sine is negative cosine, but the negative's already there, so that's going to be plus cosine theta plus c. And then number 43, the last of the odds, the antiderivative of x is x squared over 2, increase the power by 1, divide by the new power. Now this one's a little different. Let's look at it like this, 5 times 1 over x. Think about what function that you know of that has a derivative of 1 over x. Hopefully you're remembering ln of x. So that's just kind of another memorization one. So we get 5 ln of something that's new. When we go backwards, we get absolute value of x, and then plus the constant of integration c. All right, so these are the odd ones for 291. They should also help you for the evens as well as, like I said, they are parallel problems.